On today's episode of the Ag Irrigation Collective, we're going to go over some information about irrigation. Stick around. Hi, I'm Wes Schaefer, your host for the Ag Irrigation Collective. Appreciate you joining us today. We're going to go over a little document I came across. It's called Some Information About Irrigation. It's quite a simple document by Dave Bjornberg. It's a document that is available on USDA.gov website. I'll post a link to it in the show notes and in the description of the video so you can see what it is if you care to look at it. It's kind of interesting. It goes into irrigated acres within the United States and the method of irrigation that they use. We're going to just discuss it a little bit for a little bit of listening value here. Talks about here at the beginning, about half of the irrigated land in the United States is surface irrigated, meaning not sprinkled. So I would call that flood irrigation from my region. Other regions call it different. But surface irrigated is about 50%. 45% is irrigated by sprinklers, and 5% is irrigated by drip or other irrigation methods. He's got a table on this chart that shows the top 7 irrigated states. I'm going to go through those to visit about them briefly, and then it says outside of these top 7 states, all other states have less than 200,000 acres of irrigated land. I don't know if that means each state or combined. It doesn't say here, but the first state on this chart is California, starting at 8.1 million acres total of irrigated acres, 1.5 million of those being sprinkler, 5.8 million of those being surface, and then just over 1 million being drip irrigated. It's kind of interesting. Idaho's a big agriculture state. A lot of people, based on some of their policies and taxes and cost of living and the whole gamut put together, really crap on California. But if you get into farming, California, rural California, which does exist, by the way, there's some pretty awesome people. So keep an open mind as you travel through California that you need to stop into some of these farms and meet some people. Okay, moving along. Number 2 on the list, Nebraska. With a total acres of 5.692, so darn near 5.7 million acres of irrigated. Kind of shocking. The eastern part of Nebraska is quite wet. I do know it's covered in pivots. However, you get into the western side of Nebraska, and it really starts to taper off and look like, quite truthfully, a desert as you get in more over toward the west. So out of 5.7 million acres, sprinkle irrigation is 3.86 million acres, and there's just over 2 million acres of surface irrigated, which is flood, and they've got a hash mark through drip. So I'm of course assuming there's a handful of drip, but probably not enough to mean much. Number 3 on the list is Texas at 5.2 million acres of total irrigated acres, 3.2 of those being sprinkle irrigated, and then 2 million, or just over 2 million, being surface, with 55,400 being drip irrigated acres. Number 4 on the list is Arkansas with 4 million irrigated acres, 579,000 being sprinkle irrigated, 3.5 million of those being surface, and 480 acres being drip. Very, very little drip. I was actually thinking that Nebraska would be around 500 acres, and they just chose not to add that into the the data set here, but with Arkansas reporting 480 drip acres, that must mean there's really nothing in Nebraska. But that's one thing to kind of consider and think about here is there's only under 600,000 acres of sprinkle, and then there's 3.5 million of flood acres irrigated. It's kind of interesting. I know they use a bunch of alfalfa valves that I've seen anyway, as I've done some research and traveling through the countryside there, that they open up those alfalfa valves and their water is so plentiful. It's just amazing to me. I actually, being from the state of Utah and living in the state of Utah, we don't necessarily have the advantage to have abundance of water. There's plenty of parts in the state that we have plenty of water, and there's good amounts of water, but nothing like Arkansas. That Arkansas water is wild. As we get down, number 5 on the list is Idaho with 3.188 million acres irrigated total. 2.1, nearly 2.2 million of those being sprinkle irrigated, and 992,000 of those being surface or flood, with 1,080 acres being drip. So that's interesting. And as I think through Idaho, my mind goes to pivots regarding sprinkle irrigation, but you get traveling through and you start to look around, there is a pile of well lines still in Idaho. In fact, just yesterday I was traveling up through Pocatello, Blackfoot, Idaho Falls country, and there is a lot of pivots, but I will tell you too, there is a pile of well lines. So it's kind of interesting to see that. Number 6 on the list is Colorado with nearly 3 million. It's 2.942 million acres irrigated total. 1.3 million of those being sprinkle irrigated and 1.6 million of those being surface, with another hash mark through drip, signifying there's no drip or extremely small amounts of drip within the state of Colorado. Number 7 on the list of the top 7 states is Kansas. Actually, surprisingly to me, for some reason, I don't know why, without doing any research into it, that's surprising to me, but that is surprising. 2.65 million acres irrigated total. Just over 2 million of those being sprinkle irrigated and 614,000 of those being surface, with 830 acres being drip. And so anyway, that's kind of interesting to know those stats. I quite like seeing stats, and so I thought I'd kind of read those on here today. I do also want to cover the bottom part of this chart, just if there's any interest to anybody to stick around. There are trade-offs between various irrigation systems. I think we all know that. If we don't, there are. Surface irrigation has lower initial cost but requires more labor. Okay. Sprinkle irrigation, especially a center pivot, generally requires less labor but costs more to install and operate. Drip irrigation can be automated to greatly reduce labor and carefully manage water, but this increases initial costs and requires operators to have more technical skills. It also requires that if you get gophers, you're going to be in a mess if you don't catch them right now. Just my two. That's not in this document, by the way. That was my add to that. Some typical disadvantages of each type of irrigation are erosion with surface irrigation, wind loss with sprinkler irrigation, and plugged emitters with drip irrigation, and rodents. That's not an article either. So as we move down through that chart here, the first one on the list on this next little box chart deal is called Relative Irrigation System Costs. Surface irrigation having a moderate initial cost, a low operating cost, and a high labor requirement. That is true. You move down into sprinkler, and there's actually two sections of sprinkler here, hand or wheel move, And then the next one is center pivot or solid set, meaning you would leave under a solid set scenario, you would leave that throughout the season. You may move it at the end of the season to do some field work and stuff. But anyway, so sprinkler irrigation, hand or wheel move, the initial cost is moderate, the operating cost is moderate, and the labor requirement is moderate. On hand move, some may equate that out to being high, similar to surface or flood irrigation. I actually would on at least hand move. Wheel move, on wheel lines, I think we can have a discussion there, specifically with some of these fancy remote control type of wheel moves and all that type of stuff coming out. But I would think that, anyway, at least hand move, hand lines, I think I'd put those in a high category. So anyway, a sprinkler under center pivot and solid set, the initial cost is high. The operating cost is moderate. And the labor requirement is low. I'd agree with that. Solid set, though, could be then under a similar scenario because there is some initial at the beginning of the season requirements on labor as well as at the end of the season requirements. Unless when they talk solid set here, I guess my mind went to more like handline solid set that you would leave in pivot corners or something. But this could be some that's actually permanent solid set. So then under that scenario, low labor requirement is factual. And under drip irrigation, that's a high initial cost. That is true. Operating cost is moderate, and the labor requirement is low. Again, you get rodents, you get gophers. Out in that, you get plugged emitters. You're going to run into trouble, and I think then your labor starts to go up slightly. So there could be a little debate on a few of those in that category, but that chart's in general pretty darn good. Soil texture is also a factor in choosing irrigation systems. Soil texture refers to the amount of sand, silt, and clay particles in the soil. Sand is the largest particle, and clay is the smallest. As a reference, consider sand to be the size of a beach ball, silt the size of a golf ball, and clay the size of a BB. That's actually pretty good analysis and comparison to kind of put it in a picture in your mind. Soil texture affects how we irrigate soil. A sandy soil allows water to infiltrate faster than clay soil, so water can be applied faster to sandy soil. However, sandy soil holds less than 1 cup of water per gallon of soil, so it must be irrigated more frequently than a silt loam that can hold 3 cups of water per gallon of soil. Loamy soils contain uniform amounts of sand, silt, and clay. Application efficiency is another important characteristic of irrigation systems. Drip irrigation tends to have greater application efficiency than surface or sprinkler irrigation. Application efficiency can be greater than 95% with buried drip irrigation. Subsurface drip, by the way, if that's some of you don't know what buried drip irrigation would be, as buried would be the subsurface, because all of the water is applied in the root zone. Center pivots, on the other hand, tend to have application efficiencies of 75 to 85% compared to 30 to 50% for surface irrigation. You know, the other day I saw a report that was published by the NRCS on one particular grower's piece of ground that they had marked him as 75% efficient on a flood irrigation system. And I about fell on the floor. Now, the piping did replace a dirt ditch, and it's what we call insertity type of system. And so it's the black drainage pipe with T every so often, and you go pull the piece of 4 or 6 inch pipe out and irrigate that way. But that report showed that they had him marked off as 75% efficient on a flood system. This is here showing 30 to 50% on surface irrigation. I'm going to be more in agreement with this than a 75% on that. Application efficiency refers to the percent of applied water that is stored in the crop root zone. For example, a 75% application efficiency means for every gallon of water applied, only 3/4 of a gallon, 75%, is stored in the soil for plants to use. The remaining 1/4 of a gallon of water is not used by the crop, but it is not necessarily wasted. Runoff from a surface irrigated field is often applied to another field downstream. Maybe. Eventually. Water that leaches through the soil can recharge the aquifers. Yeah, I'd go for that. Much of the groundwater in southern Idaho. Have we talked about Idaho other than that earlier chart? Anyway, much of the groundwater in southern Idaho is the result of inefficient irrigation in the past. That's interesting. Without this recharge, the water table will decline and spring flows will decrease. That's interesting. That's the end of the article. I will put a link to it in the show notes there. It is on ars.usda.gov. There's actually some pretty cool articles on there. This one is one that's titled Some Information About Irrigation by Dave Bjornberg. I hope I'm saying that right. Bjornberg. I think I am. That was kind of a longer podcast than we've done on the last few episodes, but I kind of want some feedback. If any of you have any articles or things that you believe we ought to cover within the irrigation industry, any type special people we ought to get on, I do have intentions of getting some sprinkler company experts on with us to kind of visit about pivot sprinkler packages and even some efficiencies, somewhat what we discussed in this episode today. I do appreciate you guys coming and joining the podcast. If you'd be willing to subscribe, share the podcast around a little bit and the YouTube video. It does help, help us grow the channel there, and we can help everybody that's involved in irrigation stick together on some of the stuff we're up against. There are some things I would guess off into the future that we're going to run into that we as irrigation professionals and farmers and growers need to be in lockstep with some of the things that are coming toward us. And I think as we better communicate through social media and other methods, that we can better help one another out. And that's my intention through social media here, whether it be on a podcast or YouTube or TikTok or wherever you find this. We can come together as professionals, whether we're competing pivot dealers. I don't give a crap if you're a Zematic or Ranke dealer. I'm a Valley dealer. It doesn't matter to me. We need to come together as professionals within the business and go that way with it. So anyway, thanks for stopping by. Be profitable, my friends. We'll catch you on down the road.